So sets are fundamental building block of mathematics. So we first define in this lecture what is a set. So we start with the definition. So a set is a collection of well-defined and distinct objects. So a set is a collection of well-defined and distinct objects. So we will write this down. So set is nothing but a collection of objects, but these objects are distinct, and we will explain each and every term in this definition. So the objects of the set are also called elements and sometimes as members of the sets. So objects are also called elements of the set or members of the set. So also called elements of the set or members of the set. And sets are generally denoted by capital letters like capital A, capital B or capital C. So we will write this down too. So everything which I am writing down will be clear once we have examples. So sets are denoted by capital letters like capital A, capital B, capital C, capital D and so on. So now we come to examples of sets. So the first example we will talk about is, we will denote the set by capital letter A, and this will be set of odd positive numbers or integers less than 8. So you know positive integers are 0, 1, 2, 3, 4, 5, 6 all the way to infinity. So we are talking about positive integers which are less than 8 but are odd. So positive integers less than 8 are 0, 1, 2, 3, 4, 5, 6, 7. And we just take odd numbers out of them, and odd numbers are 1, 3, 5, 7. So it does not matter how we write the set. You can write as 1357 or 7315. So the order in which you write the elements does not matter. So you have a set which is 1357 and it has elements 1357. So you can also write it in another descriptive form. You can say x such that x is a positive integer and x is less than 8. So these are two different ways of writing the set of odd positive integers less than 8. Yeah. So the first form, which is 1357, this is called the extensional or the roster form of set A. So you know what integers are. There are 0, 1, 2, 3, 4, 5, 6, 7 which are less than 8, and we are choosing only odd out of them, which will be 1, 3, 5 and 7. So So the second form, which is x such that x is an odd positive integer, is called the intentional or set builder form. So it is called intentional form or set builder form. So it is x, then the column is called such that x is an odd positive integer. So example number 2. So let another set be denoted by a capital letter B, and it is set of letters forming word school. So here we will make use of the idea or the word in the definition called distinct. So set is a collection of well-defined and distinct objects. So notice that O occurs twice in the word. So instead of having it twice, we just write it once. Yeah, so notice that one O is taken out because we are talking about distinct objects or elements in the set. You can also write it in the intentional form or the set builder form as x such that x is a letter in the word school. So the first form is the extensional form or the roster form. So this is the extensional form or the roster form. And the second one, x such that x is a letter in the word school, is the set builder form. So now we want to talk about another kind of set, which is set of solution of equation. So let us write this down. So you can also talk about sets which are solutions of equations. So for example, if we have an equation like x square minus 1 equals to 0, we can talk about its solution set. The solution of equation of the form x square minus 1 equals to 0. So you know, if you put minus 1 in place of x or 1 in place of x, you get 0, or it factors out like this. So you know the solution is 1 and minus 1. So we can also write it as in the set builder form x such that x is a solution of x square minus 1. So x such that x is a solution of x square minus 1. Let us come to another example. Here we will talk about set of natural numbers. You already know that natural numbers are 1, 2, 3, 4 all the way to infinity, and positive integers are same as natural numbers, but they also have 0. So natural numbers are 1, 2, 3, 4, 5, 6 and so on. So I am writing this in set builder form now, x such that x is a natural number. So I have written two forms. The first form was roster form and the second form is set builder form. Now let us take squares of natural numbers. 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25, and then 6 square is 36, and so on. So you can now write x such that x is equal to n square, that is square of a natural number. Now we will talk about integers. We have already talked about positive integers. Now I am talking about set of all integers. So it contains all the minus and the plus numbers. So it goes from 0, 1, 2, 3, 4 all the way to infinity, and it also goes from 0 to minus 1, minus 2, minus 3, minus 4 all the way to minus infinity. So this is what is the set of integers. So we can write it in set builder form as x such that x is an integer. Example number 7. Here we talk about rational numbers. So rational numbers are of the form, rational numbers are a big set. They contain all the integers and they also contain fractions like minus half, minus 1 by 3, minus 1 by 4, minus 3 by 4, 0, 1 by 2, 1 by 3, 1 by 4, 1 by 10, and it also contains integers like minus 1, minus 2, 1, 2, and so on. So it is a big set. Yeah. So integers are contained within natural numbers. So how do we write it in a set builder form? We write it as a divided by b, where a is an integer and b is an integer, but b is not 0. So denominator is not 0.